So this is going to act as like a demonstration of how I would implement the top-down dynamic programming method to finding the Lucas numbers. So it's just going to be like a very not quick video. It'll probably take me like 10 minutes or something to go through it. But I think the reason I'm making it as a separate video on my second channel is because I think this code is going to be a bit more complicated than the bottom-up method. Even though the logic is like not that much harder, I feel. The logic is a little bit harder, it's going to be a little bit more messy, and I'm going to try to go through this maybe not in as thorough of a detail as in the previous case. If there's any new code, I'll re-explain it, but if the old codes, I'll just go through it and gloss over it. So the idea of the top-down method is every time I want the answer to a certain Lucas number, if I already have it in my array, if I have already stored the answer somewhere, I just return the answer, just use that answer. But I don't have it in my storage yet, I calculate it, and then I give the answers back out. So first I'm going to define the storage, right? So the storage will be very similar to what we had before. It will be an array of, for example, if I want the nth Lucas number, then the array has to be of length n+1. Again, it'll be all int. As a little side of what this might look like, this array will just contain a whole bunch of zeros, right? It will be an array, and initially it's all going to just be number 0. A whole bunch of zeros in there, right? And when you change the number, when you found a certain Lucas number, I can put that number into the array and it will no longer be a 0 because none of the Lucas numbers is a 0. And so the storage looks like this. If you understand coding, and you might realize that right now I've initialized an n+1 here, and I've not really initialized that n+1 anywhere yet. Just bear with me for this case. So now we're going to write the actual function, and rather than writing the function itself, we're going to first write something called a helper function. Helper function is supposed to be a function that does all the dirty work in a sense. It will look very similar to the function, the Lucas number function that we actually want, but it'll take in an extra parameter, which in this case will be the storage unit. So I can use it within the function. And the reason I'm calling it a helper function is because it's not going to be the main function that the user who wants to know the Lucas numbers will be interacting with. So first we're going to define the helper function in the same way that we define any other function, but we're going to call it a helper instead. And in this case, just to distinguish it from the actual function, I'm going to use the variable I, where Lucas helper will return the ith Lucas number. We're going to also have the Lucas storage. Now, what I want to do in this helper function is, if we already know the answer to the ith Lucas number, return it. If we don't, then we want to work out the ith Lucas number, put that number in the storage, and then return the Lucas number. So first we have to check whether we already have the answer to the ith Lucas number. And that's very simple. We check that if Lucas storage in the ith position is not 0, and if it's not 0, that means we have already changed the number in Lucas storage in that particular position, and we only change it if we have the answer to that particular Lucas number. So in this case, if the answer is no longer 0, it means we already have the answer to that particular Lucas number. And in this case, we can just return the answer in that position like that. Now, if we don't have the answer yet, we have to work the answer out. And to work the answer out, again, same 3 cases that we have before. We first check if I equals to 0 or not, and if it is, then the ith Lucas number will just be 2. If I equals to 1, then the ith Lucas number will just be equal to 1. And for any other case when I is not equal to 0 and I is not equal to 1, then the ith Lucas number will have to be found using the recursive formula. And so the ith Lucas number in this case will be the previous 2 Lucas numbers added together. Now, we're not sure if the previous two Lucas numbers have already been found or not. And so the way we're going to do, the way we're going to find what the previous two Lucas numbers are is by calling on the Lucas helper itself. Because the Lucas helper, if you remember at the end of the day, will return the ith Lucas number, except that it also handles the whole store value in the data, store the data into the array if it hasn't been, and finding out the answers and stuff like that. So the ith Lucas number is going to have to call on the Lucas helper itself, like so. Ith Lucas helper of I minus 1, and the storage plus Lucas helper for I minus 2, and also we have to include the storage because the initial function here also includes the Lucas storage, so we can have to include the storage here. It is actually the Lucas storage, like so. And so as you can see, Lucas helper, if we just look at it in this context, it just gives the I minus 1 Lucas number and the I minus 2 Lucas number. But the additional thing it does, it also handles the whole, the answer, if the answer is not there, sorting the array and all those stuff. And so now that we have the ith Lucas number, we have to first put that into the Lucas storage because we found a new answer. This is done by saying Lucas storage of I is equal to the ith Lucas number, like that. And finally, we have to return this answer because Lucas helper at the end of the day has to give out the ith Lucas number. So this is just going to say return return ith Lucas. We just say that, right? And so now we have a function that returns the ith Lucas number. The problem, as I said, is that this is only a helper function in the sense that we have to also include the Lucas storage, and that's a bit ugly. So what we're going to do is we're going to define another function. I'm going to do it up here, which is going to be the actual Lucas function. And this is just going to take in one variable, which is just the n, which is just like which Lucas number do you want? Right? So in this function, it's going to do two things. First, it's going to start by creating the Lucas storage, right? Because we need to create the storage where the Lucas numbers can be stored in. The reason that I'm not creating the Lucas storage here inside the Lucas helper itself is because the Lucas storage needs to only be created once. If I put it in here, that means every time Lucas helper is called again and again, it's going to keep creating new storage every single time, and that gets messy, and that shouldn't happen, right? So I'm going to call Lucas storage once here, and then this same storage is going to be used for all the other times we call on the Lucas helper, which is why we have to also include Lucas storage here as an argument in our statement, right? And so after we have Lucas storage, we have to find what the nth Lucas number is, and the way we're going to do so is by calling on Lucas helper. So nth Lucas will just be equal to Lucas helper for the case when I is just n, which is the Lucas number you want, and again, have to include Lucas storage in there, like so. And now we have the nth Lucas number, this function just return nth Lucas as such. And now we have a function which calculates the nth Lucas number. Now again, note that I'm not going to call on the Lucas helper at all. If I want the nth Lucas number, I can just call on Lucas there, but except I don't really want to call it n. We can check if we want the 0th Lucas number, we get a 2. If we want the 5th Lucas number, we're going to get 11. And most importantly, we want to see how long it takes to find the 50th Lucas number. Again, pretty instantly. It takes a little bit longer than before. I'm not entirely sure why, but again, it's just like marginally longer and still a lot shorter than the initial solution that I have. And so this method really works. As I said, the code's a bit messy, so it might take a bit of time for you to understand it, but you can digest it, hopefully. And I guess this is all I have to say.